Okay, good afternoon, students. This is Mr. Gee. I'm not here Monday, which is today, and Tuesday I won't be here as well. So what I've done is I put a YouTube video of the assignment that you're to do and turn it in at the end of the day. Most of it we're going to do here online, so just follow along. If you get a little bit behind, just raise your hand and ask the substitute to stop the video, and then we'll get caught up and we'll move on. So I think the video will be about 15 minutes, so that should give you about 20 minutes to get the other questions done that I don't do online. So make sure that you've got the worksheet 2.1a. The substitute should already hand that out, and you'll also need the notes that we took on Thursday and Friday, that little handout that I had you read on the real numbers. That should help you as well. I've got Word open, and so I'm going to be typing on the screen, and as I type on the screen you can go ahead and write down what we do. So that's the bell for today. Okay, let me get my screen set. Okay, hopefully everybody can see that, so I'll put your name in there, like Mr. Gee. The date would be what, the 30th or 29th? So August 29th, and whatever period you are, and we're ready to go. Okay, it says list the 5 sets of numbers that compose the real numbers. So the real numbers compose 5 other sets. You have the gigantic set, which contains all the numbers that are on the number line, and then we have the 5 subsets, and that's what you're being asked to put in here. So the first one is the natural or counting numbers. The next one is you take the counting numbers and you add the 0. It will give you the whole numbers, right? Because the counting numbers are a subset of the whole numbers. So let's put in whole numbers. The next set would be the whole numbers, and now if you take all the opposites of the whole numbers, so the opposite of 1, positive 1 would be a negative 1, the opposite of a positive 2 and a negative 2, and so when we generate this next set using that rule, we get the integers. It's your positive and negative numbers and 0, right? The integers. The next set is defined as 2 integers, written a divided by b, where b is not a 0, because we can't have an undefined number, right? You can't have division by 0, and those numbers are the rational numbers. And the last set of numbers is generated by any number that cannot be written as a ratio, where you have one integer over another, and those would be the irrational. So that's the answer to number 1, and this first part of this video will really help you with the graphic that's on the back. Say, okay, number 2, write a complete sentence that describes the integers and give an example of what the set of integers look like. So let's do the sample set first, and I'm going to go up here and get a little program called math type. So let's write the set of integers. Now we know they begin with the whole numbers, so let's go 0. Then I've got 1, 2, 3, and then everything just continues, right? And then I'll close my curly brackets and put another space there. And now, so that is the whole numbers right there. Now how do I finish generating the integers? I just told you a second ago. So let's take the opposite of 1 is a negative 1. What's the opposite of a positive 2? Will be a negative 2. And the opposite of 3 is a negative 3. So those are the set of integers. So let's close that. And so an example for the set of integers is the number set. There we go. So let's kind of write an explanation of what we did here. So the integers is composed of all the whole numbers and their opposites. There we go. Okay, so let's come down here to the number 3 now. Everybody okay with that? I think I spelled something wrong right here. Let me see here. Integers are composed of all the whole numbers and their opposites. Okay, let's go down to number 3. It says explain how the integers and the natural numbers are alike and how they are different. I'm going to let you do that one by yourself, okay? Let's go down to number 4. This is kind of a tricky one. It says give an example of one rational number. So we can use any rational number we want. So let's say we're going to use 4 divided by 5. Okay, is an example of a rational number. So it says write your rational number as a fraction. Well, we've already got it as a fraction, but let's write it as a different fraction. How can I rewrite 4/5 as a fraction? Now I could take the top. Let me just show you this for a second. So I could take this and times 4 divided by 5. That will give me 8 divided by 10, right? So what I'm going to use, let me get that out of the way again. So I'm going to use 8 divided by 10 is an example of a fraction that is the same value as 4 divided by 5. So let's write this as a ratio. Okay, let's go down here to the next line. So how would you write 4/5 as a ratio? You'd go 4 colon 5 is 4 divided by 5 as a ratio. And then we want to write it as a truncated decimal. Well, if you would take 4 and you divide it by 5, you add a 0 and make it 4.0. Well, 5 will go into 40 8 times, right? So really what we're looking at is 0.8 is the decimal for 4/5. And then it says we need to write it as a repeating decimal. Well, 8 is truncated, but the repeating we don't use because the repeating part is 0. So 0.8 and then the repeating zeros is 0.80000 is the repeating decimal for 4/5. Now sometimes in science classes you'll see something written as 0.80000, and what they're trying to show you, even though those are just placeholders, they're trying to show you that they're carrying out their degree of accuracy to 4 decimal places. Okay, let's go on to 5. It says write a short but complete sentence that describes the natural numbers What is another name for the natural numbers? Give an example of the set of numbers that compose the natural numbers. I'm going to let you do that yourself. That shouldn't be too hard. Number 6, I'm going to let you do yourself as well. Let's go down to number 7. Number 7 is very similar to the one we just did, number 4. So it says show 3 different ways of how to write the number 5 as a ratio, a number, and as a fraction. So we're going to write it as a ratio first. So 5:1 is a ratio for 5. You could also use 10:2. You could use 20:5. Those all will work because they're equivalent ratios. Let's change 5 to a number. Any number. I don't care what it is. Okay, so let's write it as a number. It can really be any number. We can write it as 25 divided by 5, 50 divided by 10. I know it's a fraction, but it's also just a general number. We could also write it as 5.00000. We could do it that way. You can do it a number of ways. So it's just a different way to write 5. So I'm going to use 25 divided by 5. I could use 25 divided by our colon 5, right, as a ratio. We already did it as a ratio, but it's still a number. So 25 divided by 5 is another number for 5. And we'll do it as a fraction. I'm going to use 100 divided by 20 is another fraction for 5. So you say, Mr. Gee, this is kind of stupid. We're just writing 5 in many different ways. And what you've got to understand when it comes to math, especially with fractions and ratios and things like that, it's the ability to take a number and write it in many different forms that allows us to simplify and then to solve equations. So that concept that belongs to the rational numbers is very, very important for you to understand. Okay, that's number 7. This is a good question. This is probably my most favorite one on this worksheet. It says, why is an irrational number irrational? Give 3 examples of an irrational numbers. Well, first of all, you have to go back to what is the definition of an integer, or I mean a real number, excuse me. Well, a real number, I mean a rational number, sorry, a rational number. A rational number is an integer divided by an integer. So remember the prefix for irrational, the IR means not rational. So if a number is rational when you have two integers divided by itself, then irrational is you have a number where it's not 2 integers divided by itself. So that's basically what our answer will be. So an irrational number is any number that cannot be written as an integer divided by another integer. And then how do you recognize an irrational number when it's in a decimal? Well, you look at its repeating decimal pattern. Irrational number, a number will be irrational because it doesn't have a repeating decimal. Also, I need to go back and fix this, people. Rational number, there we go, is any number that cannot be written as an integer divided by another integer. Also, irrational, I gotta go down to the next line, sorry. Is any number that cannot or that does not have a repeating pattern in its decimal. So you could write something like that. It may be a little bit different from mine, but I think that's what is needed. So give 3 examples. So we've got the number pi that we can use. There's pi right there. The number pi. Let's go the square root of 11. There's one. There's some other ones, but you won't know what they are. There's a number that's called Euler's number. There is a logarithmic function that's called natural logarithm. It's e. Can't really explain it right now. It's been so long since I used it. But there's a couple of other ones that have a symbol like pi. We're just going to use another one. Let's use another. I'll tell you what we'll do. Let's close this and let's get out my calculator. I know I'm saving an empty equation. It's okay. So let's get out my calculator here and let's get us another number. So let's use the square root of, let's use the square root of 5. So the square root of 5 is 236067997. So let me minimize this. So I'm going to use 2.36067977. K dot dot dot. So there's no pattern in that number, right? Are all examples of irrational numbers. Okay. Very good. Hope you're following along okay. So here's our answer for this. I need to change that to an n. An irrational number is any number that cannot be written as an integer divided by another integer. Also, an irrational number is any number that does not have a repeating pattern, its decimal. The number pi, square root 11, and then basically what was that? The square root of 5 are all examples of irrational numbers. So that's the square root of 5. So let's go down to number 9. It says, is the square root of 36 a rational number, and please explain. So is it? Well, think about it. Just because it's a square root does not mean it's automatically a rational number or an irrational number. If I take the square root of 36, I ask myself, what numbers, two numbers that are identical, do I multiply together to get 36? Well, I've got one pair that's 6 times 6 will equal 36. So the answer is yes. Is the square root of 36 a rational number? Yes. Why? Because the square root of 36, fill this out again, is a perfect square and simplifies to the number 6, which is a rational number. There we go. Alright, so that's number 9. Is the square root of 36 a rational number? Please explain why or why not. Yes, because the square root of 36 is a perfect square and simplifies to the number 6, which is a rational number. Okay, Number 10, you can use number 1 to help you, and number 11, I'm going to let you do that one on your own. So that's the end of this video. Remember to turn in your worksheet at the end of the hour, and remember that I don't take late work. Also, tomorrow you'll have another worksheet. I'm not sure. I think it will be the B1 2.1b, and then I'll also have another video that you can watch and I'll help you with that. So thank you, and I'll be glad to see you guys Wednesday, and behave yourselves. Thanks.